You might have heard that our universe began with the Big Bang. But did you know there could be more than one Big Bang? In fact, according to some physicists, there could be infinite Big Bangs, each separated by eons of time so vast they're almost impossible to comprehend. When it comes to understanding the nature of our universe, we often find ourselves at a crossroads. We humans love to categorize things, and so when faced with a seemingly endless expanse of space and time, we naturally seek patterns and order. It's this drive that led to the Big Bang Theory, which describes the universe as expanding from an extremely hot, dense state. But even this widely accepted theory isn't without its limitations. It doesn't, for example, explain what caused the Big Bang or what existed before it. In the quest for a more complete understanding, some have turned to mathematics and physics to explore alternative ideas. Enter the Big Bounce, a theoretical model that challenges the traditional narrative. Instead of the Big Bang marking the beginning, the Big Bounce suggests that it was both a beginning and an end, a single moment that links two separate periods of existence. Now you might be wondering what existed before the Big Bang, if not another bang. And the answer, well, it's a bit of a curveball. According to the Big Bounce, before the Big Bang, there was a phase of the universe that is hard to imagine because it was essentially the same but in reverse. Think of it like a wave crashing into the shore. As it recedes, it momentarily pauses, then starts to rise again. In a similar way, the universe contracts until it reaches a point of maximum density and temperature, then bounces back into expansion. This brings us to the question, how can something be both the beginning and the end? To understand this apparent paradox, let's consider the Penrose theory. Proposed by the renowned mathematician and physicist Sir Roger Penrose, it offers a unique perspective. At its core, this theory hinges on the idea that the cold, dark universe at its end behaves like the hot, dense one at its beginning. This intriguing concept is supported by the fact that certain physical laws appear in their most basic forms under conditions of both extreme cold and extreme heat. For instance, general relativity simplifies significantly near the Big Bang, when the universe was incredibly hot and dense. Similarly, at the end of our universe, when everything would be very cold and sparse, general relativity would also simplify in a particular way. Penrose took this observation to the next level. He realized that if these two states were truly analogous, it would imply that the entire history of the universe could be described by a single set of equations. This led him to propose a revolutionary idea, the notion of a single eon of universal existence. According to Penrose, our universe has existed and will continue to exist forever, endlessly cycling through phases of expansion and contraction without any true beginning or end. It's as though the universe is a character in an endless story, forever reliving the same chapters. While the Penrose theory offers an elegant solution, it's not without its critics. One of the main issues is that it relies heavily on the continuation of the current accelerated expansion. If the expansion slows down or even reverses, the universe wouldn't collapse in the way Penrose predicted. However, this hasn't dampened the spirits of those seeking a deeper understanding. Enter Edward Witten's superstring theory. Where Penrose focused on the behavior of the universe as a whole, Witten took a more granular approach. His theory suggests that the fundamental constituents of reality, the tiny strings that give rise to all matter and energy, actually lead to an 11-dimensional reality. Now, you might be scratching your head trying to wrap your mind around the concept of more than 3 dimensions. After all, we only experience 3 spatial dimensions and 1 dimension of time. But in the realm of theoretical physics, things aren't always as they seem. Witten's idea is that the additional dimensions are not only real, but play a crucial role in shaping our reality. These dimensions are thought to be curled up at extremely small scales, hidden from our perception. But they come into play when we look at the universe from different perspectives. What's more, he proposes that our universe, with its particular physical laws and constants, is just one among many. Each of these universes exists within a larger, more complex structure called the bulk of hyperspace. Here's where things get really fascinating. According to Witten, our universe is just one brain in the bulk of hyperspace. Each brain represents a different version of string theory. But why do these universes exist within a larger structure? What's the purpose of this grand ensemble? The answer, as with many things in the universe, is harmony. You see, the various versions of string theory that make up the brains in the bulk of hyperspace are mathematically very similar. This similarity allows them to interact with each other in a delicate balance. The interactions between these universes keep them stable. But this stability, like all things in the universe, is not absolute. Imagine a violin string. When it's not played, it remains still, but when it's struck, it vibrates. These vibrations can be compared to the behavior of our universe. As time goes on, the tension between the different versions of string theory that make up the bulk of hyperspace will cause them to vibrate. This vibration, this push and pull between different universes, is what drives the evolution of the universe. However, as Witten suggests, this vibration will eventually become too intense. It will reach a critical point after roughly 1 trillion years. At this point, the various brains will begin to retract, pulling themselves away from each other due to the growing tension. They'll move towards regions where the mathematical description of string theory breaks down. Eventually, the different universes will completely separate, causing the collapse of the structure known as the Big Rip. But here's the kicker. Once they've separated, the universes will start to expand again, giving rise to a new cycle, a new Big Bang. And thus the universe will begin anew. It's like a dance, a cosmic ballet where the universe contracts and expands over and over again, driven by the intricate interactions of the various string theories that compose it. The implications of such a theory are profound. It suggests that the universe isn't merely a static backdrop to our existence, but a dynamic, ever-changing entity. It implies that the constants of physics are not immutable, but can change over vast stretches of time. And perhaps most intriguingly, it hints at the possibility of other universes, other versions of reality existing alongside our own. Think of it like a grand orchestra. Each instrument plays a different note, but together they create a beautiful harmony. In this analogy, each instrument represents a different physical law or constant. And just as the different notes can combine to create new sounds, the different laws of physics can interact to produce phenomena we may not yet understand. So, what does this mean for us? How should we, as curious observers of the cosmos, make sense of these ever-evolving theories? Perhaps the answer lies in embracing the unknown, in accepting that the universe is a place of endless wonder and that our understanding of it is always evolving. Maybe the true nature of the universe lies in the harmony of all these theories, just as the music of the spheres resonates throughout the cosmos. Just as a musician fine-tunes their instrument to produce the perfect note, scientists are constantly refining their theories to better understand the universe. The Big Bang, the Big Bounce, conformal cyclic cosmology, string theory, and Witten's superstring theory, they're all pieces of this grand composition, contributing to a symphony that we are only just beginning to hear. Imagine a never-ending record player with multiple tracks playing simultaneously. As the needle moves across the vinyl, it picks up the different frequencies, creating a rich, layered sound. Each track represents a different theory, each playing a crucial role in the overall composition. Some tracks are more prominent, others more subtle, but together they create a harmonious blend. And so it is with the theories of the universe. Each one contributes to our understanding, adding its own unique perspective to the grand tapestry of reality. While we may never fully grasp the intricacies of these theories, we can appreciate the beauty of their collective composition. The universe, in its vastness and complexity, is a testament to the power of mathematical elegance and the human spirit's unending curiosity. As Carl Sagan once said, "We are a way for the universe to know itself." Our quest to understand the universe is not just a scientific endeavor, it's a journey of self-discovery. Every theory we propose, every observation we make brings us one step closer to unraveling the mysteries of existence. So, whether we're talking about the Big Bang, the Big Bounce, conformal cyclic cosmology, string theory, or Witten's superstring theory, we're talking about different ways of understanding ourselves and the world we inhabit. These theories, like the notes of a grand symphony, come together to create a composition that is at once complex and beautiful, a composition that we are still in the process of understanding.